All right, welcome back to Notes with Mr. Mays. We're going to be rolling through and looking at these 4 final questions on the 1.6 normal distribution calculation slides. So these are slides 25 through 28, and I'm going to start with question 1, which is on slide 25, right? Q1. Oh, I shouldn't write Q1 actually, because that might look like quartile 1, question 1. Okay, so you should have the question 1 up with you in front of you, and it says the graduate student collected a study of field mice in rural Kansas, blah, 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 100 field mice, weighed in grams of each mouse. After the measurements were taken, it was discovered the scale was not calibrated correctly. Okay, so the 100 recorded people, or of the recorded measurements, we're subtracting 3 grams from each measurement. Okay. Which of the following statistics for the weight in grams of the field mice has the same value? So I've already noticed that we're altering it by subtracting 3 grams, and now we want to know what's going to stay the same. And that's how I read a multiple choice question for statistics. I've got my 2 points of contact to check for. And my options are the median, the mean, the first quartile, the third quartile, and the interquartile range. Okay, so already I know, and you should know, that measures of center are going to change. Because, as we're well aware, anytime you add or subtract, you're changing the center, right? So I already know A cannot be right and B cannot be right because the median and the mean are both measures of center. So now I have 3 other components here. We do know that measures of spread do not change, so that's a good sign. Now that actually is enough information to get me to my answer, because my answer is E. Because the interquartile range, aka the IQR, is the only thing of the remaining 3 options, quartile 1, quartile 3, and interquartile range, that is actually a measure of spread. Quartile 1 is not a measure of spread. It is still a data point. And quartile 3 is also a data point. And the data points definitely have adding and subtracting happening. So for that reason, question 1, our answer, I will highlight it in green, is E. And I hope that made good sense to you. All right, moving on. Let's get away from the color blue here. Let's do some red for question 2. Question 2. And this is on slide 26 if you're following along, which you should be. Question 2 reads as follows. The weight of adult male grizzly bears living in the wild in continental United States has a mean of 600. Ooh, okay. For the males, I'm going to separate this out. This is how I think about the problem. Males has a mean of 600 and a standard deviation, right, of 60 pounds. So we're already rolling. On the other hand, the females, we have different measurements for. Female grizzly bears have a mean of 400 and a standard deviation of 50. Okay, and it says what would be, right? What is the weight of the female grizzly bear with the same z-score as a male grizzly bear with a weight of 530? So we have a male who's 530 pounds. Oh, I just made that into a time. I am all over the place. 530 pounds. Okay, well, first off, I want to say, if you take a look at our answer choices, A through D, you'll notice that only one of those answer choices is like functionally, because we're looking at a weight, right? So first of all, one of those answer choices, D, is not a weight at all. It can't be D. His D is actually 2.6, which is a z-score of some kind. Okay? So we definitely don't want D. Now, of the 3 remaining weights, you'll notice that if we're looking at a weight for a female grizzly, which we are, only one of them is even possible. And the reason I say that is because the male grizzly bear weight is 530 that we're looking at to compare. And that is lower than our mean of 600 for males. So that stands to reason that the equivalent for a female grizzly bear should be lower than 400, right? And the only value that's lower than 400 that is not a z-score is B. So for that reason, it is B, 341.67 pounds. Now, I did that without even having to do any fancy math. But if I wanted to do fancy math, I could work my way backwards. Because as we know, z-score is equal to data point minus mean over standard deviation. And if I wanted to do the math on this, I would do the male version, 530 pounds, minus the mean for the male, right, over the standard deviation, which is 60, right? And what I would do is I would set that equal because we want them to have equivalent z-scores, the same z-score. That's what the question says. So then I would set up the females the same way, and actually make some room so you can see where I'm doing it. I would do the female data point, which is what I'm looking for, x, minus the female mean, which is 400, divided by the female standard deviation, which is 50. And if you cut through all that math and solve for x here, x does indeed come out to 341.67 pounds. Just remember, you have to cross multiply here. So you will end up with 60 times x minus 400 equals 50 times 530 minus 600. And then you'll have to do your order of operations, right? Distribute, calculate all of this out, starting, of course, with the subtraction and then the multiplication, and then add over and divide. But the answer for question 2, lo and behold, is B. And there are 2 fun little ways you could have gotten there. Okay, let's move on forward to question 3. I'm feeling let's go for like a purple for question 3. Oh goodness me. Well, that's not what I wanted. I wanted a purple for the word. Yeah, there we go. Question 3. I wanted it for the pen function. And this will be on slide 27, of course, of 1.6. Okay, question 3. Local real estate magazine used the median instead of the mean when it reported the SAT score average for a student who attend Groveland High School, whatever that is. We have a bunch of graphical data. Okay, which of the following explains why in this situation the median is more accurate or is a more accurate indicator of the SAT score of the average student than the mean is, okay? And the reason we're asking about this is it is strongly skewed right. So I'm already sketching a little graph. This is the right skewed distribution. And we're looking for an explanation for why we should use the median, which will sit somewhere here, as opposed to the mean, which will sit further toward the skew. Our options are A, the mean is affected by the skewness, whereas the median is not. All right, already you should be like, A is the answer. I feel like A is definitely the answer. Why? Because the median is not affected really at all by the skewedness, and the mean is not, or is impacted. Our other options are the median is always the preferred statistic. That's not right. B is absolutely wrong. We use the mean for plenty of things, right? C, the mean will be less than the median when the data, no, I'm going to stop right there. The mean is going to be greater than the median. So that's just not even true. D, the mean should be used only when data are strongly skewed to the left. We know that can't be true. D is absolutely wrong because we don't want to use the mean when we have skewed data. The mean is when there is no skew. You can see I'm already talking myself through these problems, and this is how you should do the problems yourself. And then for option E, the median is equal to 1/2 of the sum of the maximum and minimum of SAT, and that is just wrong. The median is not the average of the min and the max. The median is the center point if you put all the points in order and find the middle. It is never an average. Median, never an average. Never. Okay. So we should have our answer. Our answer is, of course, and let's make this highlighter blue, A, because we're legends and heroes. All right, and now let's go to our final question here. What color? We're going to use Mr. Mays' favorite, a burnt orange color. Beautiful. Ugh, what a gorgeous color. So refined, so demure, so mindful. All right, this is on slide 28, right? And we are on question 4. And this is our final question, so let's make the most of it. We've got a bunch of data. We have a mean, a minimum, quartile 1, median, quartile 3, maximum, and standard deviation. And the question says data on homes recently sold in a certain town, okay? And it says an auditor determined that an error was made in the reporting areas, in the reported areas, and all the areas should have been 100 square feet greater than was reported. Ooh! So we're going plus 100 already. Up 100 square feet, okay? I know this. The areas were corrected and new summary statistics were reported. And I'm asked, what is the interquartile range and the standard deviation for the corrected areas? Now stop. Before you freak out, before you recalculate everything, remember we're asking for 2 things. We're asking for IQR and we're asking for standard deviation. Now, and this is a messy question for this reason. you will notice that IQR and standard deviation are both measures of spread. And spread can only be impacted by multiplication and division. But we are simply adding 100. That's addition. We do not need to do any calculations except for finding the interquartile range as it stands. So I want you to realize in this problem, I give you a ton of data, and in reality, you don't even have to change much of anything. Your standard deviation stays 61.0723, okay, which is good. So it can't be B and it can't be D. And our interquartile range is just quartile 3 minus quartile 1, which in this case is 1806 minus 1704. And that is equal to 102. Okay, so that must mean our answer is A, where 102 and 61.075 or 0.0723 are our interquartile range and standard deviation respectively. Okay, I hope that has made a lot of sense to you. I hope this has been of help. If you have any questions, reach out to me on Remind. Find me during office hours. Take full use of these video notes. I put them all up here, all over the place as they are, so that you are ready, so that you feel connected to the information, and so you can toy with the ideas. You're going to do brilliantly on this unit exam. You're going to do brilliantly throughout the year. And this is Mr. Mays, proud of you, signing off.